So the first one is geometric, correct? Why? Because it's got the variables in the exponent. Okay? Which means the fourth one here is arithmetic. Okay, because the variable is just down normal. Okay? So for geometric, I need to find the first term. Okay? First term is 12 times 1/2 to the 1 minus 1 power, so that's 0 power, so that's just going to be 12. I need to find then my R value. What's my R value? 1/2. Okay. Then I've got options. I can either find the number of terms, top minus bottom plus 1. So there's either 4 terms there, or I could find my nth term, and then that would be 12 times 1/2 to the 4 minus 1 power, which is 4 minus 1 is 3. 12 times 1/8 is 3 halves. Okay, so either way, depending upon which of the formulas that you want to use. Okay, in either case, the sum then of the first 4 terms is going to be, I'm going to go G sub 1 is 12 times, what is then, R to the n power. So that's going to be 1/2 to the 4th power minus 1 all over 1/2 minus 1. Okay. Or we could have gone 3 halves times 1/2, then minus 12, and then 1/2 minus 1. Okay. Either way.
Minus 12, negative 1/4.
Yeah, and then there goes negative. Yep, okay. So in either case, we get, so if I go over here, I'd get 3/4 minus 12. Well, 12 is 48/4 all over negative 1/2. Which then gives me 3 minus 48 is negative 45/4, divided by negative 1/2 is multiplied by negative 2 over 1. So I get positive 45 halves as my sum, or 22.5. Yes? Okay. A little easier to use that one than it is to use the other one. Okay. Arithmetic, I need A sub 1. A sub 1 is going to be 55 minus 10 times 0, so that's just going to be 55. Then I need A sub n, which is going to be 55 minus 70, which is negative 15. And then I need n, which is going to be 7 minus 0 plus 1, which is 8. So the sum of the first 8 terms is going to be 8 divided by 2 times 55 plus negative 15. 55 plus negative 15 is 40. 40 times 4 is 160. Yes? Okay. Gotta know when to hold them, know when to fold them. So, to sum up yesterday, an infinite series is a series that goes on forever and ever and ever and ever and ever and ever and ever and ever. We have to look for the 3 dots at the end. Okay? That signifies that it goes on forever. In summation notation, we have to look for the infinity on the as our upper limit. Okay? So those are the 2 ways that we find it. Okay? Infinite series don't have a sum if what? From yesterday. When does an infinite series not have a sum?
It's above 0.
If
Or
the
above 1.
or if the numerator is higher than the denominator. Well, it's greater than the denominator.
Greater than 1.
What are we talking about?
The
The
R value.
R value. If R is greater than 1. Okay? So an infinite series doesn't have a sum if R is greater than 1. Okay? What do we call those? Divergent series. Okay? Infinite series will have a sum that we can find if what?
R value is less than 1.
Greater than 0.
Greater than 0 but less than 1. What do we call those? Convergent. Okay. And our sum formula for an infinite series is the first term divided by 1 minus r. Okay? My question to you now is this. What happens if r is negative?
Not plus. Right.
Just go on the other way.
Can we do those? Can we do those? Well, let's try our formula. Okay. First off, what's my r value here? Negative 2. So if this was an r value that was positive 2, would we be able to do it?
Oh,
If our r value was positive 2, would we be able to find this sum?
no.
Because it would be divergent, right? Okay. So, can we do it when it's negative? Well, let's look at a couple of terms. What would my first term in this series be? 15. What's my next term? What's my next term? What's my next term? Negative 120. What's my next term? And so on and so forth, right? Does that seem to be converging towards 0? Or is that diverging away from 0? It's diverging, right? As we go out, if we were to graph this on a number line, it would start out here, and then it would get out here, and then it would go way up here, and then way down here, and then way up here, and so it's diverging away from, okay, these are getting farther and farther apart. That's diverging, okay? We want those to be getting closer and closer to 0 if it's converging. So can I come up with this sum? This one? No. So that one's not possible. So we could go back here and we could amend this to say that if the absolute value of r is greater than 1, it doesn't have a sum, it's divergent. Okay? Let's try this one. Now, what's my r value? Negative 1/2. Okay? So, what are my terms then? Let's see. What's my first term? 800. Next one. Negative 400. Next one. Positive 200. Next one. Negative 100. Next one. 50. Next one. Negative 25. And so on and so forth, right? Okay. Is that diverging or is that converging? That's converging. So we should be able to find that sum then, right? Okay, because it's converging. So let's see. Let's see if our formula would work. Okay, so the sum is going to be my first term, which is 800, divided by 1 minus my r value, which was negative 1/2. 1 minus negative 1/2. 3/2? Okay. 800 divided by 3/2. Anybody? Or that, right? Right? 1600 divided by 3 is 533 1/3. Okay? And that actually works. Okay? So we can go back here and we can amend this r value to now say that the absolute value of r has to be less than 1. So what that means is r has to be between negative 1 and positive 1, but, oops, wrong way. R can't be 0. Okay? So it works for negative r values too. Okay? Same rules apply. Okay? Outside the positive, if it's bigger than 1 or smaller than negative 1, it doesn't work. In that negative 1 to 1 range, it works and we can find it. Okay? On the back side, I believe, of your warm-up sheet, there's 2 problems. Okay? A ball is dropped from a height of 30 feet. Right? Okay. Ball is dropped from a height of 30 feet. It rebounds. Okay? So let's draw ourselves a picture of this scenario. Okay? So 30 feet. The ball goes down, right? Okay? Drops the ball. Then what happens to the ball? It stops, or what happens? It bounces and it comes back up, right? Okay? So it rebounds to 75%. So when it comes back up, how high up does it come?
22.5 feet.
Then what happens?
Goes up 16.75.
What happens first?
It goes back down.
How far?
All the way to the ground.
So how far?
Like 22.
So it goes back down 22.5 feet. Okay. Then what happens?
Then it goes up 16.875 feet.
Then it goes back up 16.875, you said, feet?
Yeah.
Then what happens?
Goes back down.
Goes back down, how far?
Um,
Whoa, 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 whoa. Come back to me. Then it goes back down 16.875 feet. See the pattern? Okay. The ball comes up, goes down, goes back up, goes back down. Okay. Now, until what?
stops.
Does it ever truly, if this were a vacuum, let's say, would it ever truly stop? No. So it'd be going on forever, right? And that pattern would be repeated, okay? Now, my question to you is, what is your R value?
3/4.
3/4?
Yes.
Right?
0.75.
Or 0.75? Right? So if I want to know the total distance that that ball traveled until it stopped, do I know how many bounces it takes until it stops? No. Okay? So it could go on forever and ever and ever, right? How do we say forever and ever and ever in math? Infinity. Okay? So we could make an infinite sum out of this, right? Okay? So my question is, the distance that it traveled for the downs. Okay? Because it travels going down, right? There's a bunch of going downs. Okay? So that would be, what would be my G sub 1? 30. What would be my R? 0.75. So the sum would be 30 divided by 1 minus 0.75. Right? Okay. So what is that? So that's 120. So traveling just downward, that ball traveled 120 feet. But what else how else did the ball travel? It traveled up. So you have to come up with the distance for up. What's the first term in that one?
22.5.
That's 22.5. What's the R value there?
0.25.
No.
Will it still be 0.75?
It would still be 0.75. Okay. How do we figure out R? What are the What are the three ways that we know how to figure out R? We talked about this yesterday. 3 ways to figure out R. Take any term and divide it by the number right before it, right? Okay, that's one way. Another way is it's the base of the exponent in sigma notation, right? Or the other way is whatever we have to multiply to get to the next one, right? Okay, so if you don't know, you wrote out the scenario, you can take 16.875 and divide it by 22.5. You should get 0.75. Okay, so the sum of the ups is going to be 22.5 divided by 1 minus 0.75. 90?
Yeah.
So the total distance that that ball traveled was,
110 feet.
how'd you get that?
Just added the ups and downs.
Added the ups plus the downs. So the total distance that that ball traveled was 210 feet. Okay. What I'd like you to do now is I would like you to try the pendulum problem. Okay? You guys know what a pendulum is? Okay. That's a pendulum. Okay. Usually see them on like grandfather clocks and cuckoo clocks have them. Okay, that's a pendulum. Tough to see on the screencast right now, but I'm swinging my keys. Pictures don't hurt, remember. Okay? All right? So if you've got a pendulum, okay, you've got a pendulum that swings 16 centimeters on its first swing. Okay, then it's going to go back how far? 14.4. Then it's going to go back how far? 12.96.
Yeah.
Then it's going to go back how far?
11.66.
With me so far, right? Okay, so let's go to the right. What is my first term? 16. What is my R value?
9/10.
You sure?
Yes.
Positive?
Yes.
Positive.
200%. Wait,
It's not.
I'm just kidding. I don't know.
Look at blue. We're only looking blue now.
Oh, it's 10.18.
It's what? 0.81. Because it's 9/10 coming back, right? But that's going to the left, right? Going to the right, it's 0.81. Okay, any term divided by the term before it. See it? Okay, all right. So the sum for the right then is going to be 16 over 1 minus 0.81.
just
Stop yelling at me, Swan. 84.2?
Yeah. Sorry, I just meant something.
No, that's okay. Okay. Then, let's go distance to the left. What's my first term?
14.4.
14.4. What's my R value? 0.81. It's the same, right? So what's that one?
1 second, please.
Oh, my Lanta.
Sorry.
You have one job to do.
75 point, we're rounding to the tens.
Yes.
0.8.
75.8.
Yes.
Okay. So my total distance then is going to be left plus right. Which is going to be 84.2 plus 75.8,
160.
160. So 160 centimeters. Now, that's one way of doing it. What's another way of doing this problem? Kevin, what'd you do?
You could have done 16 divided by 1 minus
0.9. Yep. Okay. Because it's 0.9. If you take the whole thing as a series, okay. So then you could have done it as your G sub 1 is 16, your R is 0.9, but then your sum, do not be packing up when I am talking, is going to be 16 over 1 minus 0.9, which is 16 divided by 0.1, which is 160. Okay? But you only have one then. You don't have to do that twice. Okay? Because it doesn't rebound to the same height and then reset itself, kind of a deal. Okay? With me? So it's all in how you look at it. There's multiple ways to look at this problem. Have a great day.